So for the final kind of homework hint in this lecture, I wanted to show you how you actually set up all of these equivalent force couple system problems on the beam. And there's already another example of this in the actual previous lecture module, but I wanted to show you one that's actually unique to your homework that's assigned. So here we have a beam that's supported on both ends, A and B. There is a downward vertical force applied at point A of 600 newtons. And in addition, the loading of this beam is subjected to a 900 Newton meter couple that wants to rotate in the clockwise direction. So basically the question is, how could you exert a single force on this beam that would have the same rotational and translational effect of this downward 600 Newton force along with the 900 Newton meter couple? Well, hopefully you see that basically if that 600 Newton force were to move away from point A and move along the span of the beam, then about point A, it's actually going to induce a clockwise rotation, which could correspond or kind of compensate for this 900 Newton meters. So basically, the farther out this goes, it's going to induce its own rotation. So what we're really just trying to figure out is how far out do you have to move it such that the rotation that it induces offsets this 900 Newton meters. When you actually see the way I've drawn up the diagram, hopefully it'll make a little bit more sense. But here's probably the easiest way to look at it. You're trying to find D such that the rotational and translational effects of this system to the right are equal to this system to the left. Well, hopefully you got kind of the discussion from the actual previous lecture video that in terms of having an equivalent force system, all that you have to ensure is that the sum of all forces in both cases are equal. So basically, you know that if you want to recreate the effect of 600 newtons of force in the downward direction, you have to apply 600 newtons of force in the downward direction. The only real question is, how do you create the same rotational effect about the two scenarios? And the key point is you want to choose D such that 600 times D. Now, why is that the case? Well, what is the actual moment about the end of the beam, about the reference here? Well, if you think about it, that is your perpendicular distance D. That is the actual magnitude of your force. So basically, you just want 600 times D to equal 900 Newton meters. And you can easily solve for D and find out that what will make that happen is if you move it out by 1.5 meters. So the key point is, from an equivalent force couple system point of view, having a single 600 Newton force applied 1.5 meters from the edge is the same as having a 600 Newton force applied right at the edge with an additional 900 Newton meter couple. So these are kind of confusing until you work a few of them, which is why I put all three on the actual homework assignment.